Welcome to This Day in His Story, created by American Heritage Worldwide. A reminder that every day holds something new to learn. Did you know that because of Robert Boyle's experiments and discoveries, we can go scuba diving, watch a video of underwater ocean life, ride on a steam-driven train, and use a vacuum to clean our house? Join us in learning how Boyle earned the title of Father of Chemistry and how he became the author of Boyle's Law and a pioneer of the experimental scientific method. Today we are looking at a name you probably know from a high school textbook, Robert Boyle. Boyle's Law, something about gas and pressure.
Which is fair. I mean, that equation is completely fundamental. But the man himself, when you dig into the biographies and his own writings, the textbook version feels so sterile.
It really does. That's what jumped out at me. We call him the father of chemistry, but he was living and working in a world that was still, steeped in alchemy and magic.
Oh, absolutely.
He feels like this bridge character between two completely different worlds.
He is the bridge. That's the perfect way to frame it. The sources we have, they just paint this picture of a man who's full of contradictions, an aristocrat raised like a peasant.
A deeply religious man who helped take the magic out of science.
Exactly. And a guy obsessed with the physical world, with matter, air, all of it, who, in the end, leaves us with this total physical mystery about his own body.
Yeah, we will definitely get to that. It's a great twist ending.
It is. But let's start at the beginning, because it's pretty weird.
Right. So, Robert Boyle, born January 25th, 1627, in Lismore, Ireland. And the family situation was not exactly simple.
Far from it. His father was Richard Boyle, the first Earl of Cork, one of the richest men in the British Isles. I mean, a self-made tycoon.
Okay.
And Robert was his 14th child.
14th. I mean, by the time you get to number 14, you'd think the inheritance pie is getting pretty thin.
Well, he was the 7th son. And in the folklore of the time, being the 7th son meant something. It was supposed to come with, special gifts or a unique destiny.
Okay, but in practical terms, the oldest son gets everything, right? So he's destined for the church or the army or something.
That would be the typical path. But his father made this parenting choice that I think even now is just baffling.
This is the part I had to read twice. The Earl has all this wealth, castles, servants.
Everything.
And he sends his infant son away to live with a poor local Irish family.
Yep. It sounds totally backwards to us, doesn't it? But the Earl had this philosophy. He didn't want his children to be soft. He genuinely believed raising them in luxury from birth would make them weak.
So the idea was to, toughen them up?
Exactly. Let them be raised in a peasant home to harden their constitution. It's like a 17th century boot camp for babies.
So did it work? Did he come back tough as nails?
It's hard to say. He came back to the estate when he was 2, but the sources say the transition was just brutal for him.
Right, because you're ripping him away from the only family he's ever known.
And then, to make it so much worse, his mother dies almost immediately after he returns.
Oh, wow. So you're a toddler dealing with this massive displacement and then grief on top of it.
Exactly. And most of his biographers connect that specific period of trauma to him developing a stutter, a really severe one that he had his whole life.
So that probably made him more introspective, more of a reader.
It seems so. More inclined to listen and write than to, give big speeches. But despite that rough start, the privilege did eventually kick in. The education he got was just staggering.
Tutors in Latin and French before he's even 10, and then he goes to Eton College at age 8.
8 years old. And Eton in the 1630s wasn't some gentle boarding school. It was rigid, Spartan, academically ruthless. But he thrived.
He was a prodigy. But the sources say the real game changer was what came next. At age 12, the Grand Tour.
The classic gap year for the rich kids, right? Go see some ruins, learn a language.
Yeah, but Boyle's tour took a very interesting turn. He ends up in Florence, Italy in 1641. He's 14.
And that date, 1641 in Florence, that should ring a bell for anyone interested in science history.
It's the year Galileo died.
It's the year Galileo died, under house arrest, just a few miles from where Boyle was staying.
That's just a wild coincidence. Did he even know who Galileo was?
He absolutely did, and this is the key part. Boyle wasn't just sightseeing. He was secretly studying Galileo's work. Remember, the church had banned Galileo's books.
So he's 14 in Italy, reading contraband physics.
He's learning that the world isn't governed by mystical forces, but by, mathematical laws. It's like a symbolic passing of the torch. Galileo dies, And the kid who's going to apply that same rigorous thinking to chemistry is right there in the city.
So he comes back to England with all these new ideas, but England's a mess. The Civil War is starting.
It's total chaos. But in the middle of it all, his father dies, and Robert, despite being the seventh son, inherits huge estates. He's now independently wealthy.
Which is pretty much a requirement to be a scientist back then. You needed your own money.
You did. And he doesn't become a recluse. He moves to London to live with his sister, Catherine. And we have to talk about Catherine for a minute.
His sources make her sound like way more than just his sister or his landlord.
Oh, she was an intellectual powerhouse in her own right, a huge figure in London society, but she was also a practicing alchemist. She had a lab set up in her kitchen.
A kitchen lab? What does that even mean? Are we talking about something more intense than just, like, baking bread?
A lot more intense. Think distilling herbs, mixing minerals with acids, boiling urine to try and extract phosphorus. It was messy, smelly, often dangerous work.
So this wasn't just about turning lead into gold.
Not really. They were trying to create medicines, what are called the ens veneris. It was the very beginning of pharmacology, really. And Catherine was right in the thick of it, often leading the way.
So she's his collaborator.
She was his primary partner in everything. He never married. Theirs was the central relationship of his life. But this is also when he hits a major physical roadblock. His eyesight starts to fail.
Yeah, in his early 20s. That seems devastating for a researcher. How do you do science if you can't read or record data properly?
It forced him to adapt. He had to hire assistants, amanuenses, to read and write for him. But more than that, it made him obsessed with clarity. If he couldn't see the result perfectly himself, the experiment had to be designed so clearly and described so precisely that anyone else could do it and get the same result.
So his own disability accidentally pushes science toward reproducibility and peer review.
In a way, yes. It forced a move away from, I saw this in a vision, to, here are the steps, here's the data table, you try it.
Which brings us to the centerpiece of his work, the air pump, which, I gotta say, sounds like something you'd use for a bicycle tire. Why was this machine so important?
Well, you have to understand what he was fighting against.
Yeah.
For 2,000 years, science was dominated by Aristotle's idea of horror vacuum.
Nature abhors a vacuum.
Right, the idea that empty space was impossible. Nature would always rush in to fill it. Boyle wanted to see if that was actually true.
So he builds a machine to create a vacuum?
He commissions it. His assistant, the brilliant Robert Hooke, did most of the design. It was basically a big glass sphere with a pump to suck the air out. It is a large hadron collider of its day.
Temperamental, expensive.
Leaked all the time. But when it worked, they could finally test what happens in a void.
And what did happen?
Well, they found that a bell ringing inside the globe went silent. A flame went out. Tragically, a small bird would die. They proved that air wasn't just nothingness. It was a physical substance.
And that leads directly to Boyle's law. PV equals C.
Pressure times volume is a constant. It sounds a bit dry, but Boyle had this amazing analogy for it. He called it the spring of the air.
The spring of the air.
Yeah, he pictured the particles of air like tiny coiled springs of wool. If you squeeze them, increase the pressure, they push back. If you give them room, they expand.
That's a huge conceptual leap. He's thinking about air as being made of tiny mechanical parts.
It's the birth of the mechanical philosophy. The universe isn't some magical organism, it's a machine. And his law is one of the rules for how that machine works.
And you can see the applications everywhere. Steam engines, scuba diving.
Anything with compressed gas. When you scuba dive, the pressure of the water compresses the air you breathe. If you come up too fast, that air expands in your body. The bends. That's Boyle's law right there in your bloodstream.
He also completely rewrote the definition of an element. Before him, it was earth, air, fire, and water, right?
Or salt, sulfur, and mercury for the alchemists. Boyle, in his book, The Skeptical Chemist, just cuts through all of that. He says an element is simply a substance that can't be broken down into anything simpler.
Which is the definition we still use.
It is. And he introduced objective tests. He used dyes from violets to see if a liquid was an acid or a base. Red for acid, green for base. It's the great-grandfather of the litmus test.
He's giving chemists actual tools.
Tools, not just theories. And he wanted everyone to share them, which is where the Royal Society comes in.
Right. He was a founder, and their motto was nullius in verba.
Take nobody's word for it.
I love that. It's a direct shot at the old way of just quoting Aristotle to prove something.
It was a revolution. The Royal Society said, we don't care who said it. Show us the experiment. Let us witness it.
So Boyle helps create this institution, which is basically the new authority in science. They elect him president, and he says no.
He refuses the job.
Why? I mean, it's the top job. He's the perfect guy for it.
And this is where the other side of Boyle comes in, his faith. The job required swearing an oath of office, and Boyle's reading of the Bible was so literal, he believed the scripture forbidding oaths, swear not at all, meant he couldn't do it without risking his immortal soul.
That is a level of conviction that's hard to process today. We have this modern idea that science and religion are always at war.
He would have found that idea completely bizarre. For Boyle, science was an act of worship. He famously said the glory of God is intelligence. The scientist was a priest of nature.
A priest of nature. So for him, studying an air pump was like reading a sacred text.
In a way, yes. God was the great clockmaker. By figuring out how the gears of the universe work, the pressure of air, the nature of elements, you were appreciating the genius of the clockmaker's mind.
And he put his money where his mouth was, right? He didn't just spend on lab equipment.
No, he spent a fortune funding translations of the Bible into languages like Irish and Turkish and Malayan. For him, the data of Scripture should be just as accessible as the data of science.
That idea of access is so key because alchemists were famously secretive.
Oh, totally.
Yeah.
They wrote in code. It was an occult, a hidden art. Boyle just blew that wide open. He published everything, his methods, his results, even his failures. He believed that if knowledge reveals God's glory, then hiding it is a sin.
It's basically the beginning of open source science.
It really is. He stripped the magic out of chemistry, but he somehow managed to keep the wonder.
A great way to put it. Which brings us to that final mystery we talked about at the beginning. Boyle died in 1691.
Yeah, on New Year's Eve. And it was just a week after his sister Catherine died. The sources say he was just heartbroken and basically followed her.
He was buried at a church in London, St. Martin in the Fields, but he's not there anymore.
He's not. About 30 years later, in 1721, the churchyard was being redeveloped, graves were being moved, and when they went to find Robert Boyle's coffin, it was just gone.
Gone, like stolen or just lost.
Yeah. Nobody knows. No record, no trace. There are theories, grave robbers, a clerical error. But the fact is the physical remains of the man who gave us our modern definition of matter just vanished.
The man who proved nature abhors a vacuum ends up leaving a literal one in his own grave.
It's the perfect, ironic, final chapter.
So as we wrap this up, what we have is this figure who just doesn't fit into our neat little boxes. We like to specialize now. You're a scientist or a theologian. Boyle was all of it at once.
And that's probably why he was so revolutionary. He brought a priest's moral conviction to the sharing of knowledge and a mathematician's rigor to the messy world of alchemy.
It makes you wonder, if we lose something by staying in our lanes so much today, Boyle's biggest discoveries came from merging lanes, not staying in them.
I think that's exactly right. We're so focused on specialization. Maybe the really big breakthroughs only happen when you let your seemingly contradictory interests merge, just like he did.
A little more alchemist, a little more air pump.
And maybe a little bit of that school of hard knocks, though.
Thank you for joining us for this day in his story. May the lessons of yesterday inspire you to see God's hand today and to play your part in his story now. For more faith-based learning, visit ahsworldwide.org, the homeschool for faith and family.